anytime it's skewed, look to see where the tail is, not the peak, and that'll tell you what direction it's skewed. Okay. And then this one down here I included as well. It says if the frequency of each value is evenly spread out, or roughly evenly, it doesn't have to be perfect, just like with this one here. This one is perfect, but it doesn't have to be. If it's close enough, then we're going to go ahead and say that it's uniform. And uniform ones are going to be symmetric as well. There's really not a whole lot of interesting things going on if something is uniform. So that's another option we could possibly have. The one that we want to have, ideally, when we get to chapter 7 and beyond, is this one right here. One that's symmetric, and you've got this one little peak in the middle, and then it tapers out to each side. That one's going to be bell-shaped. So this one is bell-shaped. That's the one that we're going to want to have. Another word people will use to describe that is a normal curve. So bell-shaped and normal, those mean the same thing. It's symmetric, you've got your peak in the middle, and everything tapers off to the side. So those are the ones that we're going to want to have eventually when we start talking about normal distributions in chapter 7. Okay. And then we also have modes. Mode is going to be a little bit different than what we learn it to be when we get to chapter 3 next week. Mode, when we're looking at a histogram, is just where the peak is. So when we're talking about where the mode is, we're looking for the peak in the histogram. So here you can tell there's a peak right here. This would be where our mode is. And there's only one of them, so if there's one mode, we consider that to be unimodal. So histogram is unimodal. That prefix uni means one. And then you can also have two modes. So if you have two distinct modes, it's going to be called bimodal. That prefix bi means two. Spell it right. And the trick here is it has to be distinct modes. And with the modes, they don't have to have the same exact height. So if you look here, this is a peak, and then it comes down, and then it comes back up here, and here's another peak. So even though this one is higher than this one, these are two distinct peaks. You know, if you look at the stuff around them, each one of them is a peak. So in this case, we would consider it to be a bimodal distribution. We've got a mode here and here. Even though this one is technically taller, these are two distinct peaks. So we can have them be, one is shorter than the other, and that's okay. They can still both be considered modes for the histogram part of it. And you also want it to be distinct, so there has to be a little dip in between them. I think there's one on the homework where there isn't one, and some people got confused. Maybe it was on Liz, I don't remember which one it was. But if you have one that looks like this, so if you have a histogram that kind of looks like this, where you have this rectangle and this rectangle are both very tall, we won't consider that bimodal. That will actually just be unimodal. Even though there's two rectangles, since they're really close to each other, we'll consider that one mode. It's just a little bit wider than what we're used to seeing. So this right here, because they are right next to each other, they're not distinct modes. It's just the same one. They just are right next to each other. So for this, since they're right next to each other, this is going to be one mode, not two. So if you have one with two really tall rectangles, but they're right next to each other, it's just going to be unimodal. There's not two modes. They have to be distinct. A peak, and then it comes down, comes back up, and you have another peak. And then we do also have, I don't know if it comes up in the homework. It might come up in the project, so I'll write it down here. Okay. If it has more than, more than two peaks, it is. So we can see this. Sometimes these don't really come up as often. They're not as much fun to work with because they just get a little more complicated. So we can potentially have a histogram where it's just kind of all over the place. So we can have something like, sorry for my drawing, but something like that where it's just kind of all over the place. You've got a peak here, a peak here, a peak here, a peak here. Peaks all over the place. In that case, it's not necessarily unimodal or bimodal. You've got so many peaks, we just call that multimodal. So that's technically another shape we could have. It's just not the best shape to have. If we could pick, we would like unimodal. But we could potentially have one like that if the data really doesn't have any structure to it. Everything's all kind of random. Okay, so those are histograms and describing the shape of the distribution. So before we move on, does anybody have questions about frequency distributions or histograms? Okay. So we're going to talk about now stem and leaf plots.